That sounds like it's working. We've got a fair bit of content to get through, so we'll get stuck straight into it. Hopefully, you're all in the right place. We're here to learn about how to run production workloads on Spot and save up to 90%. My name is Boyd McGeechy. I'm a senior product manager in the EC2 team focused on Spot instances. I'm lucky enough to be joined today by Scott and Gabrielle from Citadel and Mercado Libre to talk about how they have adopted Spot and how they leverage it in production workloads. So hopefully there's an opportunity for you to learn not only from me, but from some of those who have already treaded on the path that we're talking about here today. So the agenda, no admin, so we're just going to start with fundamentals of Spot and some of the common use cases. So I'm going to take about 10, 15 minutes time here to take you through some of that before I pass it over to Scott to take you through the Citadel journey. And then he'll pass it on to Gabrielle to take you through the Mercado Libre journey of leveraging Spot in production and a couple of different types of workloads to learn from there. So let's jump in. The fundamentals of Spot. Well, while I'm the Spot product manager, and I hope you come away from this session recognizing that Spot is potentially more broadly applicable than you thought walking in, I'm not going to tell you that it's useful for every possible type of workload. We have multiple purchase options, and we do recommend you leverage all three of them wherever possible. So first, on-demand instances, right? I think most people are aware of what on-demand instances are. It's how most people get started with EC2. You turn on an instance, you pay by the second. When you don't want it anymore, you turn it off, and we stop charging you a second later. It's ideal for getting started when you're building a net new application or just getting started with EC2, and great for spiky workloads that are stateful, right? Potentially not fault-tolerant workloads. Then we have reserved instances. And reserved instances, the idea is for customers to be able to say, well, hey, this workload isn't necessarily that spiky, so I don't need all the elasticity that on-demand provides. And what I'm going to do, Amazon, I'm going to commit to keep using this instance for the next 1 to 3 years. And in return, I would like a discount. And so what a reserved instance offers you is up to 70% off the price of an on-demand instance based on your commitment to continue using that instance. Great for where you have a base level of work, a steady state workload, or things like databases where you're probably not going to turn them off all that often, and obviously not necessarily something that scales in a horizontal manner. And then finally, obviously, the focus of today's presentation, Spot instances. Spot instances are ideal for fault-tolerant, stateless, or time-insensitive workloads, and obviously can save you up to 90%. So what is Spot? Well, Spot is truly our spare capacity. There's no minimum or maximum we keep available on Spot. However, to deliver the elasticity that you expect from on-demand, it's necessary for us to have spare capacity. And so when on-demand customers aren't using that capacity, it's available for Spot customers to leverage. And obviously the caveat being how we're able to give you that up to 90% discount is to say, well, when we do need the capacity back from you for on-demand customers, we give you a 2-minute warning, and then we take that server back off you. And so that's the sort of arrangement that you need to be comfortable with in using Spot instances. Some things about Spot, obviously it's low price. Low price shouldn't necessarily be used only when you're looking to do cost savings. We see a lot of people adopt Spot instances because they might be happy with what they're spending, but they recognize I could actually do 5 to 10 times more while spending the same amount of money if I adopt Spot. Obviously in the big data and analytics space, this is a place we see a lot of customers just trying to do a lot more with the same amount of money. Easy access. So what I'm trying to talk about here, Spot used to be a system where you'd need to go and learn some unique APIs that have different behavior, potentially different semantics in them. Over the last couple of years, we've been investing in making Spot available where you launch instances today and enabling best practices through those APIs as well. So Spot instances is now available in run instances. It has been for over 12 months. You just specify Spot, and all of a sudden we're launching Spot instances. A couple of weeks ago, we integrated the fleet functionality, which Scott will talk a little bit about, into auto-scaling groups as well. So now if you're using auto-scaling groups, it's possible to combine on-demand, reserved, and Spot instances in a single ASG. And then finally, one of the major benefits about Spot, not only is it about the fact that we can save you up to 90%, it's this idea that when you're using Spot, you truly have total flexibility. Right? Just like on demand, when you don't need it anymore, you turn it off, 1 second later we stop charging you. But with Spot, when you launch that, you're launching some of the cheapest compute possible. You're optimized by default. So you have that flexibility to consume and use whatever you want, whenever you want, and give it back to us when you don't need it anymore, and we'll stop charging you. and you're getting the best possible rate for compute. So we talk about spare capacity, and there's a point that I want to make which is very important. Spare capacity for Amazon is massive. When I talk about spare capacity, one of the ways that we can talk about it is how much capacity customers are actually able to capture and take advantage of in the spot market. And so this is actually a story from Clemson University. They did this over 18 months ago now, so our capacity has dramatically increased even since then. But Clemson University was able to scale up to over 1.1 million concurrent vCPUs in a single region. In a single region, they were able to turn on over 1 million concurrent vCPUs. So if you think, well, spot spare capacity, so it might not have enough for me. Well, if you have a workload that requires over 1 million concurrent vCPUs, please come see me after this. I'd love to talk to you about it. Sounds very exciting. But spare, we have a lot of it. But you might say, well, Boyd, I tried to launch 50 spot instances once, or 100 spot instances once, and you only gave me 50. So what do you mean there's this huge amount of spare capacity? Well, the one big thing we ask you to do for spot instances, which is different to on-demand or reserved, is we ask you to be instance flexible. Because while we never run out of spot capacity, it is possible that a specific instance in a specific zone might not be available, there might not be enough available for you. And so here we actually have sort of the distribution from Clemson. They use 2XLs and up, third and fourth generation instances, C5s and M5s weren't even out at the time. And that's how they were able to achieve this tremendous scale. And this is also how customers are able to run consistently in the spot market for production workloads by saying, well, hey, if you don't have any C4.8XLs, I can take some C3.8XLs if I need to. C4.8s, C3.8s. Not sure if I got that wrong. So that's the idea behind spot, is being able to take advantage of these capacity pools. So finally, some of the spot rules. We call them simple because they're a lot simpler than they used to be. So first and foremost, as I say, spot is spare. There is no minimum, there is no maximum. And so we let market forces determine the price. However, the market forces look at spot capacity over a long period of time. And so you're not going to see dramatic changes in prices. In fact, if you go look at the last 90 days of pricing history, which is publicly available, you'll see that spot prices are pretty steady because the long-term supply and demand function doesn't actually change that dramatically. And then the other big thing, for those of you who have been thinking about or exploring or using spot for a long time, bidding is not a thing anymore. You do not bid on spot instances. You used to, years ago, it's not a thing anymore. You just request capacity. If capacity is available, we're going to give it to you. And the only reason we're going to take that capacity back off you these days is if we need to give it to an on-demand customer, right? So one spot customer cannot kick out another spot customer. You just request, and we give it to you if it's available at up to 90% off the on-demand price. And I keep saying up to. The reality is you're going to save in the range of 70 to 90% pretty consistently with spot instances over the price of on-demand. And again, we do give you that 2-minute warning when we need to take it back off you. Okay, another big point. When we talk about spot, we talk about save up to 90%, but the caveat is interruptions can occur. And so we naturally spend a lot of time talking about interruptions. And so you might get it in your head, oh, they're going to take these servers off me all the time. I'm never going to be able to finish my work. I'm going to turn it on, and 20 minutes later, Amazon's going to take it off me. The reality is, and that's what this stat is saying, over 95% of the time, customers finish their own work and turn the spot instances off themselves, right? So less than 5% of the time is Amazon actually interrupting customers. So to use spot instances, you must be prepared and able to handle an interruption. Do not confuse that with this idea that it's going to happen all the time. Over 95% of the time, customers finish their work and turn instances off themselves. Finally, let's talk about some common use cases before I hand over to Scott. This is not a comprehensive list, and it's not meant to be a comprehensive list, but this is how, if you say generally, what are the workloads I should try and identify as opportunities to leverage spot? This is sort of the big four. So first and foremost, big data. Big data is an example where you might actually have state on the instance, but if that instance is interrupted, you don't lose data, you just lose work. The idea being you might have your sort of data lake in S3 or on HDFS or somewhere else, and if an instance that's been doing processing gets taken away, we can just reprocess that work. And so remember, over 95% of the time, you're probably going to finish your work and turn it off yourself. And so if every now and then you need to reprocess a little bit of work, well, it's up to you to decide, is it worth saving up to 90% in order to every now and then have to reprocess a small amount of data. Again, it's a common place as well where we see people able to take advantage of the price point and just do more with the same amount, right? It's not necessarily about saving money for big data, although you can. You may find that, hey, with $100, I can get 10 times more capacity using Spot. CI/CD, hopefully this is an intuitive one. If you're doing tests and build servers, hopefully you can handle a failure quite gracefully, because that's sort of the whole point of a testing system and deployment system. And so a Spot instance is just a different type of failure that you need to handle when you're running a CI/CD pipeline. Then web services. Now this one's a little bit counterintuitive, and I'm excited that we have Gabriel to talk about Mercado Libre's example here, because you might think, well, no, my website needs to be on 24/7. I couldn't possibly use Spot. You can't take a server off me. Well, hands up if anybody's waited for a website to load more than 2 minutes in the last 5 years. Okay, 2 people. I don't know why you're waiting that long for your website to load. Does depend on the website. Normally by the time it's a minute past, I think my Wi-Fi is broken, I'm unplugging it, I'm trying to work out what's going on. So that 2-minute warning that we talk about with Spot instances can be a lifetime for a stateless web service. And if that instance is taken away, well, the current request should complete, and all future requests get routed gracefully to the other instances behind it. So if you're designing stateless, scalable web services, you might find you're able to adopt Spot quite easily. And then finally, high-performance computing. This is a very loaded term. We find most people in the high-performance computing market use Spot for sort of grid, high-throughput computing workloads where it's loosely coupled and a single node failing doesn't sort of destroy the entire cluster. And I'm happy to say that Scott's going to talk a little bit about Citadel's experience running these loosely coupled workloads on Spot instances as well. Similar to big data, oftentimes when an interruption does occur, it's just a matter of quickly reprocessing. And ideally, the time, again, in which you lose is not important versus the up to 90% savings you're going to get. And then finally, this isn't a workload, but I've got to talk about it. It's containers. If you are using containers, and I imagine a lot of you already have a container strategy if you're not already using them in production, containers and Spot is a match made in heaven. The reason being, containers can run here, they can run there, they can run anywhere. So when I talk about instance flexibility, that's really easy with containers. And the other nice thing is most of you have probably designed modern software architectures as you've migrated applications into containers, so you're probably scalable, you're probably fault tolerant, you've probably thought about all of these things, and instance flexibility just comes out of the box with containers. So Spot is ideal for fault tolerant, flexible, loosely coupled, or stateless workloads. And so as you listen to both Scott and Gabriel talk, you might not have the exact same workload, but look for these commonalities in the workloads and then go and look for them in the workloads that you run on premise, in the cloud today on EC2, or even if you're running them on premise and say, well, hey, does my workload have some of these characteristics? And if it does, there's a good chance you can start taking advantage of Spot instances today. Scott.
Good afternoon. My name is Scott Donovan. I'm a senior cloud engineer with Citadel. Citadel is a multi-strategy hedge fund founded in 1990 by Ken Griffin. We currently have over $30 billion in assets under management and are consistently ranked one of the top multi-strategy hedge funds on the planet. We have roughly around 1,800 team members currently. We're headquartered in Chicago, but we have offices around the globe. I've been at Citadel now for over 15 years, and the vast majority of that time has been spent designing and building systems to help our quants and analysts run their analytics at scale. And that's what brings me here today. I'm going to share with you some information about a system that we built about 2 years ago that's powered by AWS Spot fleets. So what I'm going to talk about first is I'm going to talk about the kinds of analytics we run or the kinds of workloads that we run. I'm then going to give you a high-level overview of the system that we built. And then I'm going to walk you through a specific use case that runs on that system. And then finally, I'm going to share with you some of the insights that we gained in using Spot fleets for the past couple years. So let's get started. As I mentioned, we're a multi-strategy hedge fund. And while each strategy's analytics are significantly different, they typically fall under the same 4 categories. There are research workloads. That's when an analyst or a quant might have an idea on how to increase the profitability of a portfolio or perhaps reduce the risk associated with a portfolio. What-if scenarios. Reactionary workloads. That's when a human or an automated system determines that there's been significant enough market volatility to warrant rerunning some of our analytics in the middle of a trading day. We also have overnight workloads. At the end of the trading day, you gather up the most recent inputs for your models, and you run them at large scale to prepare for tomorrow's trading day. And then there's model backtesting. When you make code changes to a model, you've got to test those changes. And sometimes those tests involve iterating over 10 to 20 years worth of historical data. These are extremely resource-intensive workloads. But it's really critical that we get them done quickly, because the faster we can test our changes, the faster we can move our changes into production. And that just means that's the faster that our company can react to the changing market landscape. In 2014, we determined that our computational needs were soon going to outpace our computational capacity. So either our data center teams were going to need to get really busy racking and stacking new hardware, or we were going to have to change the way we did things. We decided to do a POC in a public cloud. So we took one of our proprietary scheduling systems, and we moved it into a public cloud, and we used it to drive a 45,000 core model backtest workload. Now, for the most part, the POC worked well. We learned a lot doing it, which was the important part. The 2 key takeaways: 1, Docker is a really useful technology for migrating workloads from on-prem into the cloud. And the second key takeaway that we learned was that none of the proprietary schedulers that we had built over the years were particularly well suited to orchestrating Docker containers. So we were going to need a new system. So we looked at a handful of open source tools that are out there. We looked at some enterprise solutions. But at the end of the day, we decided to build our own system on top of the Nomad job scheduler from HashiCorp. Now, I'm not going to get into the details of that decision process. We did speak at HashiConf. You can find the video out on YouTube. Or if you'd like, after this talk, you can meet with me, and I'll be happy to discuss it with you. The new system that we built is named Orc. Orc was built by our cloud infrastructure team, which I'm a member of. It's a 4-person team that's helping drive public cloud adoption across the firm. The cloud infrastructure team is part of a much larger platform engineering team, which helps steer the technical direction of the firm in general. So this is a high-level system diagram of the Orc system. As you can see, it's multi-region. There are 2 regions on-prem at the bottom of the diagram, 2 regions in the cloud at the top of the diagram. Inside each region, you'll see a little green cube with an N in it. That represents a Nomad and Consul server cluster. We use Nomad for job scheduling, and we use Consul for health checks, load balancing, and service discovery. You'll also see a lot of green squares on the diagram. Those green squares represent a Nomad and Consul client node. They're the worker nodes, the nodes that your Docker containers run on. The Orc system has 2 endpoints. It has a job submission endpoint labeled J, and it has a provisioner endpoint labeled P. Users interact with the job submission endpoint to get their jobs on and off the cluster, and users can interact with the provisioner endpoint to spin up compute clusters in AWS. Now, a cluster is a construct that we came up with, and it basically equates to 1 or more AWS spot fleets. What I'm going to do now is I'm going to show you a specific use case that runs on the Orc system. This particular use case is for a European trading desk, and it typically runs at anywhere from 2,000 core scale to 15,000 core scale during trading hours, and then overnight it usually runs at about 30,000 core scale. A couple of new elements on the diagram. We've got a work queue. This particular use case is implemented in terms of a producer-consumer work queue because it's simple, it scales, it works. We've also added an autoscaler. The autoscaler subscribes to state change events on the queue. And when it sees specific state change events, it will submit requests to the system on the user's behalf. We've also added a worker container. The worker container houses the model binaries. They're the part or the component of the system that's actually performing the calculations. So the way the system works is a user pushes jobs onto a queue. Now, the job basically just contains storage bucket location information for the worker so that he knows where he should read his inputs from and where he should write his outputs to. So the user pushes work onto the queue, and the autoscaler sees that state change event. And he makes a call to the provisioner to spin up a cluster or a collection of AWS spot fleets. He also makes a request to the job submission endpoint to tell the system to start the user's worker containers on those spot instances as they come up. And when the workers come up, they basically just connect back to the queue. They pop a unit of work off the queue. They go read their inputs in from S3, perform a computation for a few minutes, and then write the results back out to S3. And the workers just continue iterating over this process until there's no longer any work left on the queue. When the queue is drained, the autoscaler notices, and it submits a request to the provisioner to shut down all the spot fleets, and it submits a request to the job submission endpoint to tear down the worker containers. So it's pretty simple. In the next couple of slides here, I'm going to show you some graphs of the system metrics for this particular use case. What we're looking at here is queued work over time. Time is on the x-axis, and the queue depths are on the y-axis. Now, I mentioned this was for a European trading desk. You'll see the first burst of activity comes in at about 3:15. That's actually the beginning of their trading day. So you'll see 2,000 jobs get put on the queue quickly drains. A little bit later, 8,000 jobs get put on the queue, quickly drains, and 15,000 jobs get put on it later, and again, it quickly drains. This kind of illustrates the bursty nature of the system. Work's coming in and out of the system all day long. Now, this graph is showing running workers over time. And what you'll see is when the first burst of activity occurred right around 3:15, that pretty quickly we started to get workers starting up. And our clusters came up to scale, and then they processed all the work, and the workers were shut down. Again, very bursty nature. This graph is giving us a little bit of insight as to what's going on with our spot fleets. What we're graphing here is the requested fleet size, and that's the blue line, and the current fleet size, the purple line. So the current fleet size is basically an indication of how many cores you have that are currently up and usable. So when the current fleet size line converges with the requested fleet size, that means that your cluster's up to scale. It means you have all of your spot instances, they're all up, they're all running. So when you look at the first burst of activity here, you'll see that it took just under 5 minutes for us to get all of our compute resources. And later, in the second burst of activity, it took just a little over 5 minutes. And in the last burst of activity, there's all kinds of crazy things going on in this slide. What happened was the user put work on the queue. The autoscaler noticed it. It started up spot fleets. The workers started, and work started being processed. Computation started occurring. And then about 5 minutes into that, the user decided to put even more work on the queue. The autoscaler saw that and determined that it was going to need more compute resources. So it submitted a resize request to the provisioner, which basically just passed that request on to the spot fleets. And that's why you see that step function. Now, these next couple of charts are basically the same information, but it's for a different time window. The time window that we just looked at was during trading hours. This is during the overnight hours. And as I mentioned, typically overnight workloads are a little bit larger in scale. This particular overnight workload, about 600,000 jobs were put on the queue. And you can see that there's a pretty consistent downward slope to the draining of the queue. That's what we like to see, because what that indicates is we're not getting impacted by any significant termination events. Running workers over time, what you can see is that we pretty quickly get up to about 22,000 workers. Now, we're spinning up a 30,000 core spot fleet, but we're only getting 22,000 workers. The memory footprint of our workers is such that we can't always make use of every single core on the VMs. Another thing to notice, though, about this chart is we get up to 22,000 workers, and then it stays pretty consistent at that scale. So it's not bouncing around. We're not getting hit by termination events. Now, Boyd spoke a little about termination events. They're not ideal. But for use cases like these, it's really not that big of a, it's not a problem. What'll happen in this particular use case if we get hit by a termination event, any of the instances that are shut down, whatever the workers were working on, that work is just going to show up back on the work queue. And the next available worker is going to pop it off the queue, and it's going to rerun the job. So while termination events aren't ideal, it's not that big of a deal for this kind of use case. And again, the requested versus current fleet size graph, what this shows is that we went from 0 to 30,000 core scale in 15 minutes. So that's pretty big, pretty fast. Since we're here talking about spot fleets, I just give you a little bit of insight into how our provisioner works. Our provisioner is a REST service. You basically post a JSON request to its cluster endpoint, and it will start up spot fleets for you. You have to provide some information in the request. You have to specify the provider, AWS, the size of your cluster, in this case 20,000 cores, and you have to give it a machine type. Now, right now we have 3 different machine types: standard, high mem, and compute. And I'll talk about those in another slide. But for now, just know that there are 3. Another piece of information that you need to provide the provisioner with is, do you want an ephemeral cluster or not? Now, what an ephemeral cluster means to us is that we're going to build that cluster out of AWS spot fleets. If a user says ephemeral is false, what we're going to do is we're going to build them a cluster, but we're going to build it out of on-demand instances. Now, while you can use our provisioners to spin up clusters constructed of on-demand instances, nobody does it. The spot fleets work so well and they're so inexpensive that nobody provisions on-demand resources with our provisioner. You can also resize a cluster through the provisioner, and you saw an example of that in the system metrics that we looked at. And then obviously you can delete a cluster. I just want to briefly touch on the definition of a spot market in case any of you are new to spot instances or spot fleets. What we're looking at here is a spot instance price history graph for the C5 2XL instance type over the past 3 months. Now, what I want to point out here is we are not looking at a single spot market. We are looking at 6 spot markets. The spot market is the unique combination of instance type and availability zone. And then the supply and demand of that instance type in that availability zone is what drives the price. So we have a couple things with our spot fleets and with our clusters that are important to us. The first and foremost, we want them to come up very quickly, or as quickly as possible. Also, we want to minimize the size or scope of any termination events that we get. Now, by using a diversified allocation strategy, we can actually achieve both those goals. When you use a diversified allocation strategy, you're basically configuring your fleet to start up in multiple spot markets in parallel. So you build into your launch spec a large number of spot markets that you're willing to accept resources from, and it will start up across all those different spot markets. So not only does it get your fleet up quickly, but it also has a nice side effect that your instances are spread out across a large number of spot markets. So what that means is you have fewer instances in any individual spot market. That way, if you do get a termination event in a specific spot market, odds are you don't have an awful lot of compute in that individual market. Machine type classifications. What we did was we took a look at all the different instance types that Amazon supports. Some of them are optimized for memory, so we group those in a high mem categorization. Some of their instance types are optimized for compute, so we group those into our compute categorization. And then we took everything else and we left it in standard. So what we're doing here is we're abstracting away from our users the need to know anything about AWS instance types. They don't have to know how much memory is on which instance type and how many cores are on which machine type. They just need to tell us if their model is more sensitive to memory or more sensitive to compute. And we'll do all the work of building launch specs for them. One other thing that we're doing, we were an early adopter of spot fleets. And when they first came out, you could get a spot fleet up more quickly if you submitted a few in parallel. So instead of requesting a 30,000 core spot fleet, if you requested 4 7,500 core fleets, you would ultimately end up getting your 30,000 cores quicker. Now, from what Boyd tells me, you don't have to do that anymore. So at some point, we'll remove that code. But that is what we're doing now. So what did we learn over the past couple of years owning and operating this system? First off, make things as simple as possible. Using spot fleets is not that hard. But I don't want my users to have to worry about allocation strategies, about spot prices, about launch specifications. I don't want them to have to know anything about those things. So abstract it away from them if you can. Just want to take a quick poll. How many people here have ever misplaced an EC2 instance? Come on, get your hands up. Okay. What I'm talking about is you get to the end of the month, you're doing a billing function, and you're trying to determine which teams are going to be charged what for what cloud resources they consumed. And you find 2 EC2 instances that are up and running that should have been shut down a week ago. Mistakes happen. Now, when a mistake like that happens, you basically end up having to pay a few $100s extra for resources that you didn't actually use. Misplace a 30,000 core spot fleet. I dare you. So what we found is that you want to be really tight in how you control these things. So if a user doesn't have any need to scale up larger than 2,000 cores, don't let them. Build in a limit, just like Amazon does. Put a limit on their account so that they can't get bigger than 2,000 cores. If a user isn't going to need to run a cluster for more than, let's say, 3 hours, automatically shut it down for them in 3 hours and 5 minutes. Don't let the user make a mistake and forget to shut it down. Shut it down for them. Monitoring and alerting. Obviously, that's important in any system, monitoring and alerting. But when you have bursty large-scale systems like these, you could potentially have 3 or 4 or 30,000 core spot fleets up and running. And if your system isn't working correctly, you're spending an awful lot of money to be doing nothing. So it's really critical that if something is broken, you get a human involved as quickly as possible to just minimize the cost of your system outage. Diversified allocation strategy is the key to getting your fleets up quickly and as well minimizing the impact of termination events. And to illustrate that, when we first built the system, we did not understand this. We only had 32 instance pools in our launch specification. And the time that it took our 30,000 core clusters to get up to scale, or for all of our spot instances to start, was about 50 minutes. I mean, it's almost an hour. So the only change we made was we changed our launch specification, and we added more spot instance pools to it. That's all we changed. And by making that simple change, we reduced the startup time of our fleet to about 15 minutes. So we got a 70% speed up in the startup time. And finally, I don't think any talk about spot instances or spot fleets would be complete unless you touch on the cost savings. So what we're seeing is about a 70 to 75% reduction in the cost over their on-demand pricing. So thank you very much for your time. And if you have any questions for me, we'll be hanging out in the hallway somewhere after the talk. Thank you.
Sorry. Okay, hi everyone. I'm Gabriel. I'm Senior Infrastructure Manager of Mercado Libre. And in this part of the meeting, we want to show you our little but intensive journey in terms of cost saving and how we use spots to save tons of money in Mercado Libre, that it's a very different workload. It's for mission critical workloads. So, what is Mercado Libre? Mercado Libre is the biggest e-commerce and payment platform in Latin America. We have more than 200 million users, and also we serve tons of thousands of transactions a day. And to support that, we have a large infrastructure, a large IT organization on top of the company. We have almost 3,000 applications today, on top of 20K machines on AWS, that supports 50 million records per minute. And to manage that, we have 2,000 engineers that they have their focus put in the product of Mercado Libre itself, that they make 2,000 deploys a day. And as you can imagine, we are in an AWS conference. The 20K, it's a big number for us at least, and it's good to see how we manage that and how we manage that in terms of cost. And to be honest, in terms of cost, before and after January. And why that? Well, we are a growing company, so we just moved to the cloud, and we started to see that we have a bill every month. We started to see that the bill started to grow a little, but as we are growing, a fast-growing company, we say, okay, that's normal. Things are growing, costs are growing. It's pretty well. Then, after a couple of months, we started to see that we started to grow a little more than the business. And after that, we started to see that that was much more than the business. And our finance team comes to us and say, hey, guys, you should do something. That can't continue. So after that, we did something. So what we did, we say, hey, we will reduce the bill. There's no problem. However, we are a growing company. That chart shows us that we are growing in terms of application. We moved almost 100% in the amount of application in the last year, and almost in deployment. So reduce the bill is important, but keep your business growing is important too. So how to manage that? How to manage that trade-off between keep growing and reduce the cost? Well, we started to check the different options. We had a lot of meetings with Amazon, also with Boyd. We started to see that we have a lot of options, reserve instance, spotting, server flavor. Also, we explored cut fingers. We had some regulation problems there. But as you can imagine, this is a spot presentation. We decided to start to explore spot deeper. And the first one that we found that spot are really great. As Boyd mentioned, you have up to 90% of discount. You have almost the flavor supported, predictable price, and also, that is very important, you don't have commitments. So you don't need to say, hey, I will use that, or hey, I will prepare that. No, they prepare that. No, you just say, I will use that today, and maybe tomorrow, no, it's okay. However, there is, and not everything is magic. They can be destroyed at any time. So how to use something that can be destroyed at any time in a mission critical deployment? And that was that we started to figure out how to solve. So to understand how we did it, or how we use it, the first a little about the Mercado Libre infrastructure. Well, the infrastructure, as the same case that the Spot mentioned, all our infrastructure is managed through an internal platform. In fact, it's pretty similar in some cases to Spinnaker, just to show you. Every machine is created through the platform, not directly by the developer, sorry. Almost our infrastructure are web servers, so they can be destroyed at any time. They are Java application or Go application or whatever, but almost they are web servers. And also, because the application is running in our platform, we know how much critical is that application for our infrastructure, how much affects that application to a business metric. And that is very important for the next slide. So in terms of infrastructure, we have a large platform, we have tons of machines, but it's very easy. It's very simple. We have just a couple of load balancers, around 6,000, but everything is a load balancer, an auto-scaling, and a couple of instances. That we say, okay, if we have instances, we just add more instances in that are cheaper, that are spot, and then shrink the pool. That's it. In fact, we did it in a couple of days, I think. It's very, very simple to do that. There wasn't 2,000 engineers working on that. It just was a couple of guys. And today, in the last week, I think that Amazon presented, or the last month, Amazon do that also. You can use the mixed instance type auto-scaling, where you can say, hey, I would like to have 50% in spot, 50% in on-demand, and Amazon solved that problem. But when we started to do that, we should implement. So that runs very well. In fact, we have moved almost 60% of our infrastructure to spot instances, and believe me, we saved tons of money. However, when we started to check that, we started to ask ourselves different problems in terms of how to do that. When to start to spotify, or when to run that job. How many spots used per pool? At least when you start, you say, hey, 100%, it's cheaper. What happens if an instance dies, and how to manage that? And also, how to deal with the auto-scaling, the different auto-scaling processes when we are working on top of that. Well, the first one for us, at least, was easy. We are a daily basis workload, so we should say, hey, do at the night, just to reduce the problems. We also run some tests on the day, and there is no problem. It's just add machines or remove machines. It's very easy. However, just to prevent downtime, do at the night. The second one, and that is very important for us, it's how many spots use. You are mission critical. You can't be down. How to prevent downtime in terms of you should consider that all the spots can be destroyed at the same time if you want. So to solve that, we make a kind of risk account in terms of how much critical is an application for the business and what is the probability of an instance die, of a spot instance die. We also estimate that, and doing that, we decide how much instances we want to have in a pool. And with that, and based on the criticality of the application, we can do a mix of them. For example, we are in e-commerce, so our items API, it's very critical for us. So there, we just put 30% of the instances as a spot instance. Why 30%? Because we estimate that if we lose the 30%, the application will be up without problem, maybe a little slow, but it will be up at the same without any problems. However, in the other hand, we have, for example, a pictures pool that it's behind the CDN. So if the pool goes down, there is no problem for a couple of minutes. And there we just put 100%, because if we lose, there's no problem. If we lose the entire pool in 5 minutes or 10 minutes or 20 minutes, it's not a big deal for us. However, it's a big deal to save tons of money having the 100% there. So that was very, very important for us, and I recommend you that estimate how much spot do you require in a pool, and how much risk you want to take. Because believe me, the spot instances will die. So what happens if the instance die? Very recommendable to have the event, the 2 minutes event, because it gives you the possibility to remove, for example, in our case, the traffic from that instances. So that makes a very friendly stop of the instances. So believe me, at least for us, where we have a lot of requests, 2 minutes, it's a lot. Maybe, I think, don't talk to a boy, but 30 seconds for us, it's a lot also. But 2 minutes is a lot. We heard the event, and then after we heard, we just go to the load balancer, hey, remove that instance from the pool, and that's it. Then we expect that Amazon collect the instances. So what happened? Nothing. It's very important that you consider that just for a stateless workload. You shouldn't put a database here. That is very important. And also, it's very important that your workload can be automated. They should be automatic. Why? Because you should expect that the instance will die, and then you should create a new one. And it's very important that everything should be automatic there. And the last one, in our case, where we add and remove instances, was very important what happened with auto-scaling, because if you have an auto-scaling and you add 5 instances, you have 5 instances. You add 5 instances more, there's no problem. The problem is that if the auto-scaling starts to destroy instances because maybe your CPU is going down, you will start to destroy your spots. So you will start to pay more, and it's not that you want. So what we did, it's a kind of predictive scaling where we just set the amount of instances that we will need for a period. And with that, we prevent that the spot will be removed. However, if we have some spikes, for example, in traffic, CPU, or wherever, we can add on demand to prevent downtime. Also, today, with the new auto-scaling, you can prevent that and also add more spots. We are in the process to explore the new feature to move on, because it's also, when you are scaling, you want to save money too. So, the important part, the results. Well, that was impressive for us. We almost duplicate our consume hours in the first chart. However, the ratio between cost and hours have been very, very down. It has spiked down. And that was awesome for us. In fact, if we see the total cost, that it's very important, if we see the bill, we almost duplicate the consume hours. However, the total cost just grow 30% or something like that. And that was awesome, because it was the trade-off that we want. That was, we can keep growing, we can keep creating new machines, we can keep using more CPU without increasing the bill at the same rhythm, at the same time. And that gives us the possibility to keep growing without keep growing our bill a lot. So, some lessons that we learned there. First one, very important, do the math. The Amazon bill, it's very complex. You have a lot of things. There are many other costs beyond machines. For example, in our case, was also networking. So do the math in your case, and just analyze which is the best for you. As boys say, you have on-demand, reserve, and also spot, and you have a lot of things to consider. Second one, spots are really great. We love them. However, using them with responsibility, because they can be destroyed at any time. So it's very important that you choose the exactly point where you want to put the spot, and you should consider that the spot will be destroyed. So you should design your application thinking on that. It's recommended that you design your application thinking on that every time, because also the on-demand instance could die. It's just to think that they could die frequently. That's all. Cost management needs to be performed continually. It's something that we learned. It's not just do something and that's all. It's something that you need to work every day, because the bill counts every day. And also, there's not silver bullet like in every place. And we say that because if you explore the different options without cut fingers, you have reserved instance, spot instance, and other ones as different options. In fact, there are multiple options. We use all of them to make a good cost approach in Mercado Libre. Thank you very much, guys.
Thank you. Thank you both for coming in and sharing your journey. Hopefully you found some insights from both Scott and Gabriel on their experience. Obviously, please do complete the survey if you enjoyed the presentation. Otherwise, don't worry about it. Yeah, as Scott said, we're going to go hang out in the hallway, answer some questions if you've got any. So yeah, please join us. And thank you again. I know it's late on a Thursday, so thank you for coming.